Hello, if you're watching this, it's because you are doing this assignment at home. So I'm just going to walk you through how to do the first page, and then you should be able to do the other pages by yourself. It can be a little confusing. There are instructions, so you should be able to get through whatever you need to, but if it's not making sense, then follow along with me. Okay, so the first part, it says copper reacts with molecular oxygen to form copper oxide, which is what gives the Statue of Liberty its green color. This process is represented by the following chemical equation. This equation shows that two atoms of copper react with one molecule of oxygen to form two molecules of copper oxide. Everything to the left of the arrow is considered a reactant, and everything to the right is considered a product. So that being said, number one says, in the chemical equation above, highlight the substances that are reactants and underline the substances that are products. So you're going to come up to this equation and you're going to highlight the reactants and underline the products. So take a second, pause this video, and go do that on your assignment. Okay, now that you're back, let's do it together. So you should have highlighted this side. So I'm going to go here to the highlight button, highlight it, and then you should have underlined this side. Okay, so copper plus oxygen, these two are your reactants. They're the things that you're going to mix together to make the reaction. And then your arrow is always going to point towards your products. Okay, products are underlined. So here's your products. Your copper oxide is your product. Now that we know these are reactants, these are products, we can answer number two. What similarities do you notice between the types of atoms that make up the reactants compared to the types of atoms that make up the products? So looking at both sides of the equation, what do you notice about the types of atoms? Are they the same or different? Go right and answer there. Okay, once you've written your answer, think about this. Okay, do you see two types of atoms? Yes, we do. We see copper and oxygen on this left side, and we see copper and oxygen on the right side. So we have the same types of atoms on both sides of the equation. They're just rearranged differently. Okay, number three. Number three says make a bar graph to compare the total amount of each atom in both the reactants and products in the equation above. So we're using this equation above. We got to find how many copper and oxygen atoms that we have, and then we're going to graph them. So first thing is to find out how many copper and oxygen atoms we have. So I'm going to show you this photo. This is how I drew it on the board. So this is just your reactants, the first side of our equation. Okay, so this side, 2Cu plus O2. And you're finding how many coppers do we have, Cu is copper, and how many O's do we have, that's oxygens. Okay, so if we have this number in the front, this big 2, that's going to apply to everything after it. Okay, so we have 2 coppers, because it says here, big 2, we have 2 coppers. Then over here we have an O2. If there's a little 2, that's going to apply to everything before it. So in this case, we have 2 oxygens. Okay, and you don't need to write this down, but you need to understand this, and you're going to have to do this on the next page. Okay, next, these are your reactants. So it's 2 copper oxide, and you can see that we have this 2 in the front. It's going to apply to your coppers and your oxygens. So that means that we have 2 coppers and we have 2 oxygens. Okay, so notice we have 2 coppers, 2 oxygens both times. So in the reactants and the products, we have the exact same number of coppers, exact same number of oxygens. So you're going to come here and graph this, and how you're going to graph this is on your paper is you're going to double click to open it. And it should open up this drawing for you. And you're going to come up to the corner here and you're going to click on one of these squares. So I'm going to click on this reactant square. And it's going to change, and I'm going to change the color of it. So I want to color code these. So I'm going to do the reactants as yellow, the products as, let's do them this light blue. Okay. Now I'm going to come over here and it tells me in this table what we just found out, which is that in the reactants we had 2 coppers and 2 oxygens, and the products we had 2 coppers, 2 oxygens. So I'm going to come down here and it says copper first, so I'm going to do reactant color yellow, and for copper reactants we had 2, so I'm going to highlight up to 2. I'm going to choose the paint bucket and choose yellow. Okay, so that shows us we have 2 coppers in the reactants. Then we also have another copper, right, in the products. So we're going to do a blue color to represent our products. We have the number of 2, and I'm just going to change it from up here. Okay. Then we're going to do the same thing with oxygen. We can see for oxygen we have 2 oxygens in the reactants, 2 oxygens in the products. So I'm just going to go through right now and highlight those. Okay, and then you're going to go do this on your own paper. So pause the video and go complete this just like this. At the end, you're going to click Save and Close, so it should look like this. Okay, after you're done with that, you're going to move on to number 4. It says, how do the number and types of atoms in the reactants compare to the number and type of atoms in the products? This is a very similar question to what we just were asked, but we're going to restate it again, and we're going to say, we can see that the number, so our 2 coppers, let's look at copper, okay? We can see that copper, we have the same types of atoms, copper and oxygen in the reactants and products, and we have the same number in the reactants and products. Then it also says, use evidence from the graph to support your answer. So you're going to look up here and you're going to say, if you look at the graph, it shows you that we have the same amount of coppers in the products and the reactants. They're the same bar. They go to the same height. That's all you need to do for number 4. Then lastly, we have number 5. Okay, if you read through this little table, it will really help you to understand how to do this. What we are doing is, first, we've already separated this table out down here into reactants and products. This side is showing us how many atoms we have in the reactants, which we already found out. We have 2 coppers, 2 oxygens. And then in the products, we also already said we have 2 coppers, 2 oxygens. So now what we have to prove is that the reactants and the products weigh the same, that we didn't lose any mass. So to do that, we need to figure out how much does each of these atoms weigh. So this first one is done for you, and it says 64 plus 64 equals 128. Well, how did they get that? We know that we can get the mass of one atom, of any atom, from the periodic table. So you're going to look at the periodic table, which you can click on this link right here to look at it. And it's going to open up the periodic table for you, and you're going to find copper in the periodic table, which is right here. And you'll see that we have this number on the bottom, 63.54. That rounds to 64, and that is your atomic mass. So you know that one copper atom weighs 64 units. They're called AMUs, or atomic mass units. And so we come back here, and they have 64 plus 64. The reason why they have 2 is because, look, we have 2 coppers. So really what they did is 64 times 2, right? And we want to find out how many coppers, what's the mass of all of the coppers in this whole side of the equation. So 64 times 2, or 64 plus 64, and you get 128. Now we're going to do oxygens, okay? So how much does an oxygen atom weigh? We're going to go back to our periodic table. We're going to find oxygen, which is right here. We're going to see that's 15.99 is our mass there on the bottom. That rounds up to 16. So I go back to my assignment. I know we have 16 atomic mass units and 1 of my atoms. But guess what? I have more than 1 atom of oxygen on this side. I said I have 2. So I'm going to do 16 times 2. And I'm going to get my answer of 32 atomic mass units. So in the end, all I need to do down here is add these up. 128 plus 32, that equals 160 total AMUs. All right, pause the video, and now you're going to go through do that same thing on this side in this column. Okay, now that you're back, make sure to answer question 6. It asks you, how does this number and this number compare? Okay, are they the same? Are they different? Explain why that is. All right, the rest of this you're going to be able to do on your own. I'm just going to walk you through this last couple parts. The first thing you're going to do for this page is you're going to look up the mass of carbon, the mass of oxygen, and mass of hydrogen on, again, your periodic table. Again, it's that number on the bottom, okay? And you're just going to write them in there. Then here, you're going to highlight the reactants, underline the products, just like we did above in this chemical equation. So our reactants are on this side, so I'm going to highlight them. And our products are over here, and I'm going to underline them. And that's just for you to clearly see which ones are which. That being said, we're going to come over here, and we're going to do what we just did up here. Okay, but this is a little more complicated. You're figuring out how many carbons, oxygens, and hydrogens do we have in this first side of the equation, and you're putting those numbers down here. Then you got to figure out the total mass of all your carbons, oxygens, and hydrogens on this side. So let's do the first one together. Okay, so I've already done this, so let me just show you a picture of it. This is your chemical equation. This is how you figure it out. You start with carbons. You have 6. How did we get that? Well, we found that up here in this, you have 1C, and the only number that's going to affect it is the big 6 that's before it. So that shows us we have 6 carbons. Then we look at oxygens. Okay, we have 2 spots to look at oxygens. The first spot is right here. We have 2 numbers that are going to affect it. This 6 out in the front and this little 2 after it. So whenever you have 2 numbers like this that are applying to one letter in the chemical equation, you're going to do multiplication. So you're going to do 6 times 2, so that gives us 12. Okay, but then we still have over here 1 more oxygen that we have to account for, and that's going to be affected by this big 6. So we have 6 of these oxygens over here. So we're going to do 12 from over here, and 6 O's from over here, and then in the end you have 18 O's. Lastly, you have a hydrogen. Okay, a hydrogen's over here. We're going to do the same thing that we have 2 numbers affecting it. We have this big 6 out front, this little 2 back here. You're going to multiply those together just like we do with exponents in math, and you get 12 hydrogens. Okay, so write those down on your assignment in this column. 6, 18, 12. Once you're done with that, you're going to come to this column and you got to find the total mass of all of this whole side. Okay, so you're going to start with just carbons. What are the mass of all of the carbons on this side? How you're going to figure that out is you're going to take the mass of carbon from up here and multiply it by how many carbons you have. Okay, so in this case, our mass of carbon was 12 from the periodic table. So we're going to do 12 times 6 and get our answer there. And that is how you're going to finish the rest of this assignment. You're going to go through, calculate all the rest of these. You're going to make 2 graphs, one for the amount of atoms, which your amounts are here, and one for the mass of your atoms, one for here and one here. The only key that's tricky here is that when I go to edit this graph, we already have some numbers in, and sometimes your numbers aren't going to line up perfect. So let's say that for hydrogen, I got 6 atoms that I had to go to. Well, we don't have 6 on my graph, so I'm just going to round up to 8. Going to put that in, and then I'm going to write in this box the number that it's supposed to be. Okay, so that's how we're going to get around the fact that we can't do a half box on the computer. So you're going to round up to the nearest number and then write in the top what number you should have gone to. Okay? You should be able to do the rest. You got it? The whole point of this is to prove that conservation of matter happens with chemical equations and to show that in a model of a graph. Thanks, and have this done and ready to turn in at the end of the class on Wednesday the 9th.